이번 동영상은 그 H 매트릭스 이게 사실 하밀토니안이라고 써놨지만은 사실은 이게 심플레틱 매트릭스인데 하여간 이 심플레틱 매트릭스 have the following properties. None of the eigenvalues of the simpletic matrix are equal to zero. H inverse의 이게 하면 또 이거 트랜스포즈 빠졌습니다. Since H inverse power of the definition was symplectic matrix from equation 357, H is non-singular by definition and therefore does not have any zero eigenvalues. If lambda is the eigenvalue of a symplectic matrix, then so is one reciprocal lambda. Since H inverse J inverse H transpose J we obtain 하면은 이렇게 쭉쭉쭉쭉 해서 이거는 이거 같죠. So if lambda is eigenvalue of H, then it is also an eigenvalue of H inverse. But it's also true that if lambda is an eigenvalue of H, reciprocal of lambda is an eigenvalue of H inverse. The only way to reconcile these two facts is to realize that if lambda is eigenvalue of H, then reciprocal lambda is also eigenvalue of H. The determinant of the symplectic matrix is equal to plus minus 1. Since H inverse equal J inverse H transpose J, we obtain 이래 하면은 이게 H transpose고 이게 H하고 다 같은 거죠. But it is also true that the H inverse determinant H inverse the inverse of the reciprocal of the determinant of H. Combine this with the equation 362. We see that H 그러니까 H determinant가 H determinant inverse와 같은데 이걸 이래 되려면 결국 H inverse는 플러스 마이너스 1의 값을 갑니다. If symplectic matrix does not have any eigenvalue with a matrix equal to 1, then half of the eigenvalues will be outside the unit circle, and the other half will be inside the unit circle. Let us write lambda as diagonal matrix that contains all of the eigenvalues of H, symplectic matrix, that are outside the unit circle, assuming that none of the eigenvalues are on the unit circle. Then the Jordan form of H can be written as like this, where the matrix is the diagonal matrix of eigenvalues. The psi matrix can be partitioned into the 4 n by n blocks as like this. Note that 2m by n matrix psi 1 1 psi 2 1 contains the eigenvectors of H that corresponds to the stable eigenvector of H, that is the eigenvalues are inside of the unit circle. The n by 2n by n matrix of psi 1 2 psi 2 2 contains eigenvectors of H that corresponds to unstable eigenvalues of H, that is eigenvalues that are outside of the unit circle. Equation 344 can be written, 그 부분은 지난 동영상에 보여줬죠. 이렇게 나오면 요 부분이 우리가 그래서 여기 파이 D5 여기 H 매치죠. 예. 그리고 이쪽으로는 살 넘기면 이래 368 되고. Now we define the n by n matrices y1k and the y2k are 2n by n matrix yk as follows. 이렇게 나누면 이거 전체를 y로. Note in equations 370 and that the psi one inverse 1 is not the inverse of upper left of the partition of psi. The matrix psi inverse 1 is rather the upper left n by n partition of psi inverse. Similar statements hold for the other partitions. With the definitions, we can write equation 36a as y2k plus 1 and y2k 되면 y21 되면 20, 22 되면 21, 23 되면 22, 23, 2k 되면 람다 k의 2배. Similar 람다 1k는 minus k 되면 equation 3 이거 람다 375 37 넣으면 이렇게 되고 as k increase lambda minus k matrix per zero because it has a diagonal matrix whose elements are all in less than 1 in magnitude. Therefore, for large k, we have k, sk, 375, 375수 그러면 이렇게 되고 sk 이렇게 되고 y2k는 이렇게 되고 sk는 그냥 384를 383에다 넣으면은 어떻게 돼요? 이렇게 돼요. 리콜그 3, PK, SK 돼요. SK는 이렇게 되고 385, 386에 보면은 그 PK가 무한대로 가면은 결국 이걸로 왔다. Equation 387 gives us a way to determine the steady state solution of the Dare discrete arithmetic Ricard equation. However, this analysis assumed that large lambda was diagonal matrix with all elements outside the unit circle. In other words, if the Hamiltonian matrix, statically speaking, symplectic matrix has any eigenvalues with a magnitude equal to 1, then this analysis falls apart. The Hamilton approach to steady-state Kalman filtering first formed the Hamiltonian matrix, strictly speaking, symplectic matrix like this. For n-state Kalman filtering problem, the Hamiltonian matrix will be 2m by 2m matrix. Compute eigenvalues of H. If one of them are on the unit circle, then we cannot go any further with this procedure. The Dare does not have a steady-state solution. Collect n eigenvectors that correspond to n eigenvalues that are outside the unit circle. Put these n eigenvectors in a matrix partitioned is like this. The first column of this matrix is the first eigenvectors. The second column is the second eigenvector, etc. Psi 1, 2, psi 2, 2 or n by n matrices. Compute steady-state Ricard equation solutions as like this. Note that the psi 1, 2 must be invariable for this method to work. 자, 요 방법론을 갖고 예제는 example 7에서 보여드리도록 하겠습니다. 감사합니다.